Good morning, children. Today I am going to discuss about the first unit given in chemistry, that is the solid state. You know very well that the universe is made up of two types of entities, matter and energy. And this matter exists in three states, that is solids, liquids and gases. Solid state, it exists in solid state, liquid state and gaseous state. And in this unit we concentrate more about solids. General characteristics of solids. Solids example you can give many. We use many solids in our daily life. A blackboard, a chalk, everything, our body, everything, they are in solid state only. So what are general characteristic properties of these solids? Number one, already I've studied in 9th standard, they have definite mass, they have definite volume, they have definite shape, and the intermolecular distances between the particles, that is constants, are very short. But at the same time, the intermolecular forces between the constant particles are very strong. The constant particles here mean they may be atoms, maybe molecules or ions. So solids have definite mass, volume and shape. The intermolecular distances between the constant particles are very short, and the intermolecular forces between the constant particles are very strong, and these particles have fixed position and they can only oscillate about their mean position. And solids are highly incompressible and they are rigid. You know the meaning of rigidity? Solids are usually called as what? The rigid matter, we say. So what is the meaning of rigidity? Rigidity means they have the tendency to maintain their shape. Why they are maintaining their shape? Because they occupy a fixed position and the intermolecular distances are very short and intermolecular forces are very strong. So that's why they are rigid. So you understood now the meaning of rigidity, but they can only vibrate about their mean position. So they are highly incompressible. So now you understood the general characteristics of solids. They have definite mass, volume and shape. Intermolecular distances are very short and intermolecular forces are very strong. Fixed position. That means they occupy a fixed position and they can only oscillate about their mean positions, and they are highly incompressible and they are rigid. So please concentrate. Why solids? Important question here. They ask in board. Why solids are rigid? Because they have the tendency to maintain their shape. The reason is they occupy a fixed position but can only oscillate about their mean position. They are highly incompressible. Now these solids, the general characteristic properties we have discussed already. Now how they are classified? They can be classified in many ways, and one of the ways is they are classified based on the arrangement of the constituent particles, whether they are orderly arranged or disorderly arranged throughout the solid. So based on that, they are classified into two types. One is amorphous, another is crystalline. So solids can be classified in many ways, and one of the ways is based on the arrangement of particles, constant particles in the solid. So they are classified into two types. One is crystalline and another one is amorphous. Now here what is coming in your mind? Crystalline. Whenever I say crystalline, already you made a crystal in 11th standard, copper sulfate, which is triclinic in shape and blue in color. A beautiful crystal you made from the impure powdered sample. So crystal, and again we are using crystal in our kitchen, that is sodium chloride crystal we are using, right? So crystal means they have definite geometry, they have definite shape. So from this you can understand crystalline meaning. And this year also you are going to prepare the crystalline solid ferrous ammonium sulfate, which is also called as more salt. So now we discuss here the crystalline and amorphous. So what do you mean by crystalline solids? Crystalline solid usually consists of a large number of small crystals, each of them having a definite characteristic geometrical shape. So they have definite geometry. Many examples you can give here. As I told already, sodium chloride, potassium nitrate, potassium chloride, many salts what we use in lab. So they have definite geometries. It belongs to a crystalline character. So a crystalline solid means usually consists of a large number of small crystals which has definite geometry, shape. And in a crystal, the arrangement of constant particles are ordered. So ordered means, the regular pattern of arrangement of particles is that you could see in the crystal. The particles, say for example, you take sodium chloride, it is ionic solid, you know very well. I used to tell in the class whenever we ask the formula for our table salt, we should not say NaCl, we should say Na plus Cl minus, because it is an ionic solid. It is a polar solid, right? So in this NaCl, Na plus and Cl minus is orderly arranged, and the shape of our sodium chloride is, it is a face-centered cubic crystal. So it is a crystalline substance. That means it has definite geometry. What geometry? It is a face-centered cubic geometry it has. So the arrangement of particles in the sense here, Na plus and Cl minus, it is orderly arranged throughout the crystal. You take one piece of a crystal, orderly arrangement will be there. So throughout the crystal, the orderliness is there. Such crystals we call it as what? Long range order crystals. So a crystal means the arrangement of constant particles is ordered. It has long range order. What is the meaning of long range order? It means that there is a regular pattern of arrangement of particles which repeat itself periodically over the entire crystal. So they'll ask one question here. What is the meaning of long range order crystal? Whether your crystalline solid is the long range order or short range order, they will ask. What it means? It means there is a regular pattern of arrangement of particles. Particles means atoms, maybe molecules or ions. So particles which repeat itself periodically over the crystal. Now you understood what is a crystalline solid. So solids are classified based on the arrangement of constant particles into two types. One is crystalline, another is amorphous. Now I think you understood what is crystalline solid and its definition. Now coming to amorphous solids. Amorphous solids, they are short range order. Crystalline solids are long range order, but amorphous solids are short range order. Amorphous solid consists of the particles of irregular shape. Crystalline means they have definite geometry, but here they don't have definite geometry or shape. The arrangement of constant particles, that is atoms, molecules or ions, in such solids, they have only short range order. What is the meaning? There is no regular arrangement of particle. Here, in such an arrangement, a regular and periodically repeating portion is observed over a short distance only. Up to particular distance only, the particles are orderly arranged. After that, that order is what? Disturbed. So, throughout the crystal, the particles are not orderly arranged. That's why they are called short range order. So, a regular, again, and a periodically repeating pattern of a constant particle is observed over a short distance only. That's why they are called a short range order. They don't have definite geometry. Now you understood what is crystalline solid and what is amorphous solid. The picture here, it is clearly explaining you the distinguishing amorphous and the crystalline solids, how the particles, the red color and the green color. First one is the crystalline solid, second one is amorphous solid. There is no regular pattern of arrangement of particles. Such portions are scattered and in between the arrangement is disordered. So disorderly arrangement is there. That is called amorphous solid, we say. Next, we are going to distinguishing this amorphous and crystalline solid. First we understood what is crystalline solid and what is amorphous solid. Crystalline solid means they have definite geometry and they are long range order solids. But amorphous means they don't have definite geometry and they are short range order solids. And another difference is crystalline solids have sharp melting point. But amorphous solids, they soften over a range of temperature and can be molded and blown into various shapes. So crystalline solids, they have sharp melting point. You already measured the melting point of some substances in lab. they have sharp, particular temperature, sharply they melt. But amorphous solids, they don't have sharp melting point. On heating, they become crystalline at some temperature. Even amorphous solids, some solids, if you take and heat it, they become crystalline at some temperature. Such substances, we call it as crystallites. The crystalline portion of amorphous is called crystallite. So on heating, they become crystalline at some temperature. Some glass objects from ancient civilizations are found to be looking, milky in appearance because of some crystallization. So this is a very, very important question in board. Why the ancient, the glass objects, they become milky after some years. They look milky. Why? You might have seen in many places. What is the reason for that? Because of crystallization, because of the temperature changes. While during summer, the temperature is very high. So what will happen, the amorphous part becomes now crystalline. So that's why they look what? Milky. So very, very important question. Because of crystallization. And amorphous solids, they have the tendency to flow. So these solids are called pseudo-solids or supercooled liquids. So they have the tendency to flow. You might have seen the glass pan windows. They are thicker at the bottom than at the top. Why? What is the reason? Because they have the tendency to flow. That's why they are called, they are not true solids. They are pseudo-solids or supercooled liquids, we call them. I think you understood what is the crystalline solid and what is amorphous. How many ways you can distinguish. Second point is they have sharp melting point crystalline, but amorphous, they don't have sharp melting point. The next difference is crystalline solids are anisotropic in nature. What do you mean by anisotropic? That is, some of the physical properties like electrical resistance or refractive index show different values when measured along different directions in the same crystal. You see the picture here. See blue color dots and red color circle. It represents the arrangement of particles. Suppose you take sodium chloride means Na plus and Cl minus, like that. So they are orderly arranged, right? So if they are orderly arranged means you measure these physical properties, that is electrical resistance or refractive index, their values, if you take one direction, one value you get, because the arrangement of particle you see, the lines given A to B. If it is A to B, this direction, if you measure the particular property, then it gives one value. Because arrangement is what? The blue dots are there. Suppose you same physical property, electrical resistance, if you measure along the direction C to D, this direction, if you measure, the arrangement of particles differs. One red circle is coming, again blue dot is coming. So arrangement of particles differ. So naturally, these values, electrical resistance also differs. Such property we call it as anisotropy. Anisotropic means the physical properties, electrical resistance or refractive index, when measured, they give different values along different directions. So this one direction they give one value, another direction they give another value. This arises because different arrangement of particles in different directions. Since the arrangement of particle is different along different direction, the value of the same physical property, that is electrical resistance or refractive index, is found to be different along each direction. But amorphous solids you take, particles are not orderly arranged. So whichever direction you measure these physical properties, the value will be same. That's why they are isotropic in nature. So amorphous solids are isotropic and crystalline solids are anisotropic. It is because there is no long range order in them and the arrangement of particle is irregular along all the directions. The crystalline solid, the arrangement of particles are regularly arranged. Suppose you measure the physical properties, that is the electrical resistance or refractive index. In this direction you measure, the arrangement of particles like this. So you get one value. The same crystalline solid, same property, electrical resistance, if you measure in this direction, the arrangement of particle is what? Different. One red circle, one dark blue dot, like that. So arrangement of particles in this direction is different. But here it is another way it is arranged. So it is a regular pattern only, but when you measure in different directions, the properties you get different values. Depending upon the direction, you get the value. Why? Because different arrangement in different direction. So I hope you understood crystalline solids anisotropic in nature, and amorphous solids, they are isotropic in nature because they are short range order, no regular arrangement of particles along the direction, all the directions. So I hope you understood what is crystalline solid and what is amorphous solid, and what are the major differences between crystalline solids and amorphous solids. Now the same thing, only in the tabular form it's given here. This is a very, very important question. So the first question what I told is solids are rigid. Why they are rigid? Because they're constant particles, they occupy a fixed position and they can only oscillate about their main position. They are rigid. Intermolecular distance is very short and intermolecular force is very high. And solids are classified into two types, crystalline and amorphous, based on the arrangement of constant particles in the solid. Constant particles means maybe atoms, maybe molecules or ions. Now you can distinguish them crystalline and amorphous. Here table form it's given. Number one is shape. As I told earlier, crystalline solids have definite geometrical shape. Amorphous solids, they have irregular shape. Melting point. Crystalline solids have sharp melting point and characteristic at a particular sharp temperature only they melt. But here they gradually soften over a range of temperature. Next, cleavage property. Suppose you cut your crystalline solid with a knife. What will happen? When cut with a sharp edged tool, they split into two pieces and the newly generated surfaces are plain and smooth. You get a clean cleavage. Apple, suppose you get a clean cleavage, right? So like that, you get a clean cleavage when you cut with a knife crystalline solids. But the same thing in the case of amorphous, when you cut with a knife, a sharp edged tool, they cut into two pieces with irregular surfaces. You won't get a smooth surface there. Next, heat of fusion. You've studied already in thermodynamics. What is the heat of fusion? Heat of fusion means solid is converted into liquid state. At a sharp particular temperature only it happens. And heat of fusion. Heat of fusion means the heat required to convert 1 mole of a solid substance into a liquid at a particular temperature is called heat of fusion. And unit is, very well, kilojoules per mole. And in the case of crystalline solids, they have definite and characteristics heat of fusion. But amorphous solids, they don't have definite heat of fusion. Next, whether it is anisotropic or isotropic. Anisotropy or isotropy. Crystalline solids, they are anisotropic in nature. Amorphous solids are isotropic. Once again, I am repeating what is anisotropic. Anisotropic, in the case of crystalline solids, the constant particles are orderly arranged. So when you measure the physical properties like refractive index or electrical resistance, we get a different value in different directions. But in the case of amorphous, irregular arrangement, they are short range order. So when you measure the physical properties in all the directions, whichever direction you measure, the value will be same. That's why they are called isotropy. So here I used to remember, anicry. You can remember easily anicry. Cry means crystalline. Ani. You can remember shortcut method, remembering this terms anisotropic. What is anisotropic and what is isotropic you should know. But how will you remember? Anicry. Anisotropic, crystalline. Next, order in arrangement of constant particles. They are long range order. Long range order means the arrangement of constant particles are regular throughout. There is a repetition of the arrangement of particles. Throughout the entire crystal, the pattern is what? Regular arrangement. Orderly arrangement is there throughout the crystal. So regular arrangement of constant particles which repeat itself periodically over the entire crystal. But amorphous solids, they are only short range order. I hope you understood this difference between crystalline and amorphous. Now you take only crystalline solids. How they are classified? Again, the crystalline solids divided into 4 types. Molecular solids, ionic solids, metallic solids and covalent solids. Based on what? Based on their nature of intermolecular force. Intermolecular force between the constant particles, they differ from solid to solid. Crystalline solid to solid. So based on the nature of the intermolecular forces between the constant particles, they are classified into 4 types. What are they? Molecular solids, ionic solids, metallic solids and covalent solids. three types of crystalline solids, four types of crystalline solids. Some examples given. This you have already drawn NaCl here. And this is, can you recall what you have drawn? Diamond. It is diamond. And this is a graphite. Diamond, graphite and NaCl, the structures are given. Okay. Molecular solids. These are further divided into non-polar molecular solids, polar molecular solids and hydrogen bonded molecular solids. So again, crystalline solids, they are classified into four types. One is molecular solid, another is covalent solid, third one is metallic solids, fourth one is ionic solids. We discuss now the first type of crystalline solid. Again, crystalline solids are classified based on the intermolecular force between the constituent particles, four types. Among the four types, one of the types is molecular solids. And these molecular solids again classified into three types: non-polar molecular solids, polar molecular solids and hydrogen bonded molecular solids. First we discuss about non-polar molecular solids. Polar and non-polar, you know the meaning. So these solids, non-polar means no charge separation, you know very well. These solids are very soft and non-conductors of electricity. They have very low melting point and they are usually in liquid state or gaseous state at room temperature and pressure. And they are held by weak van der Waals force, you know very well. London force. Van der Waals force means how many types of forces are there, you know very well. Dipole force, dipole induced dipole force, instantaneous dipole and induced dipole. So again, London force or very weak van der Waals force will be there. Coming to the polar molecular solids, again the molecules like HCl, SO2, etc., they are formed by polar covalent bonds. The molecules in such solids are held together by relatively strong dipole-dipole interaction, and these solids are very soft and non-conductors of electricity. Their melting points are higher than those of non-polar molecular solids, yet most of these are gases or liquids under room temperature and pressure. Example, sulfur dioxide. You can give any example. Third type is molecular solids, hydrogen bonded molecular solid. Hydrogen bonded, you know what is hydrogen bond? So the molecules of such solids contain polar covalent bonds between hydrogen and fluorine, or hydrogen and oxygen, or hydrogen and nitrogen atom. Strong hydrogen bonding binds the molecules of such solids like water. They are non-conductors of electricity. Generally, they are volatile liquids or soft solids under room temperature and pressure. Here, some examples already I have shown. Molecular solid, water. Water, you know very well. Hexagonal layer like structure will be there. Diamond, it is atomic solid. And ionic sodium chloride, the structures given. So three types, I hope you understood: hydrogen bonded solids, non-polar molecular solids and polar molecular solids. Now coming to ionic solids. Ionic solids, well-known example, sodium chloride, Na plus and Cl minus. Ions are the constituent particles of ionic solids. Such solids are formed by the three-dimensional arrangement of cations and anions bound by strong Coulombic forces, that is electrostatic force of attraction is there, and these solids are called ionic solids. Ionic solids, they exist in ionic form and there is a strong electrostatic force of attraction between the ions, and they are very hard but brittle in nature. Why they are brittle in nature? Because the bonds are non-directional and they have high melting point naturally, because the force is a strong force, that is electrostatic force is strongest force. So that's why they have high melting point and boiling point. Since the ions are not free to move about, so they are electrical insulators in the solid state. 10th you might have studied, come across the same thing. Ionic solids, they don't conduct electricity in the solid state. They are hard and the particles will not move at all. But at the same time, in the aqueous state or in the molten state only, they conduct electricity because ions are freely moving there. So that's why the molten state or when dissolved in water, the ions move free to move about and they conduct electricity. I hope you understood this. And this is the clear structure of our sodium chloride. I told already the shape of sodium chloride, it is a face-centered cubic, alternate arrangement is there. This is Cl minus, here it is taken, and you know very well cation is smaller in size and anion is always larger in size. So normally in all the solids, you know, in general, the anions, they form a crystal lattice, and cations will occupy the voids, that is holes, interstices. Now coming to the third type, that is metallic solids. Metallic solids, metals are orderly collection of positive ions surrounded by and held together by a sea of free electrons. Suppose you take iron rod, it is made up of iron atoms, and each iron atom has outer shell electrons and inner shell electrons and nucleus. And inner shell electrons and nucleus both are collectively called positive kernel, Kernel, kernels we say. And outermost shell also has electrons. That shell we call it as what? Valence electrons. So metals are orderly collection of positive ions surrounded. Positive ions here, it means what? Inner shell electrons and the nucleus. And outer shell electrons, they are not stationary, they are mobile. So metals are orderly collection of positive ions surrounded by and held together by a sea of free electrons. Free electrons means what? Valence electrons. Every atom contributes some valence electrons, and these electrons are not stationary, they are mobile. And these electrons are mobile and are even spread out throughout the crystal. And each metal atom contributes one or more electrons towards this sea of mobile electrons. I told already, every atom, metal atom, suppose iron you take, iron atom, outer shell electrons there, and each iron atom contributes some electrons from the outer shell. Whatever electron it has, it is donated by each atom, right? And that electrons of each atom, you know, they form a, they are not just near one atom, they are mobile actually, and they form a sea-like appearance. So all the atoms mobile electrons are forming a sea. These electrons are mobile. So each metal contributes one or more electrons towards this sea of mobile electrons. And these free and mobile electrons are responsible for the high electrical and thermal conductivity of metals. You know very well, you studied in lower class itself, metals are good conductors of heat and electricity. Why? What is the reason for that? The reason is this only. So each metal atom contributes one or more electrons towards this sea of mobile electrons, and these the mobile electrons are responsible for the electrical as well as what? Thermal conductivity of a metal. When electric field is applied, these electrons flow through the network of positive ions. They move automatically towards which side? You know, suppose you apply electric field, they move towards positive side. Similarly, when heat is supplied to one portion of a metal, suppose you introduce a stainless steel spoon in sambar, when sambar is prepared by your mother or by you. I hope you also preparing now because of coronavirus. You are also familiar with what many recipes. So when you prepare any hot item, right, so by mistake you introduce a metal spoon inside and you forgot to take. So suppose you touch after a minute, what will happen? You know, you feel hotness, right? The other one end only is there inside the sambar or kurma. The other end naturally gets what? Heated. Why? Because it is an alloy. It is a mixture of metal only again. So when heat is supplied to one portion of a metal, the thermal energy is uniformly spread throughout by free electrons. Another important characteristics of metals is their lustre. You know very well, metals are lustrous and they are colored in certain cases. This is also due to the presence of free electrons in them. So metals are highly malleable, you know very well, and ductile. Malleability and ductility. You know the meaning of ductility and you know the meaning of malleability. Malleability means it can be beaten into sheet. Ductility means it can be drawn into wires. So metallic solids, their general characteristic properties here clearly mentioned. They are good conductors of heat and electricity, and they are lustrous. Some are colored. Again, everything, the reason is what? Because of the presence of free electron only. They are ductile and they are malleable. Example for crystalline solids, quartz, SiO2, both are silicon dioxide only. This is in the crystalline form, this is in amorphous form. Now coming to the fourth type, that is covalent or network solids. A wide variety of crystalline solids of non-metals result from the formation of covalent bonds. You know what is covalent bond? Covalent bond means mutual sharing of electrons, bond formed between the adjacent atoms because of the mutual sharing of electrons. And this covalent bond is there between the non-metals throughout the crystal. They are also called giant molecules and they are very strong. The bonds are strong, but compared to ionic force, it is weak only. These are strong and directional in nature, and they are held by very strongly at their position, and they are hard and brittle. They have extremely high melting point and may even decompose before melting. They are insulators, they don't conduct electricity. Here some examples are given. One is diamond, and you know very well carbon is an sp3 hybridization. This is graphite. The third one is silica. Diamond, it has a crystalline lattice. In diamond, each carbon atom undergoes sp3 hybridization, and each carbon is surrounded by 4 other carbon atoms, and hybridization is sp3 and the shape is tetrahedral, and a carbon-carbon bond length is 154 picometer. Coming to graphite, it has a hexagonal layered structure, and the layers are held together by weak van der Waals forces, and distance between the two layers is 340. Between the layers is 340 picometer, and each layer is composed of a planar hexagonal rings of carbon atoms, and a carbon-carbon length within the layer, that is this distance is 141.5 picometer, and each carbon in hexagonal layer undergoes sp2 hybridization and makes a 3 sigma bond with 3 neighboring carbon atoms. And now fourth, sp2 hybridization means one electron is free. It is not involved in hybridization because carbon, the electronic configuration is 1s2, 2s2, 2p2 in the ground state, and in the excited state 2s1, 2p3, and 1 s orbital and 2 p orbitals are involved in hybridization, and 1 electron in the p orbital is not involved in hybridization, so that electron is free now. So that fourth electron forms a pi bond, and that's why graphite is slippery. So this makes the graphite slippery, which makes the electrons move and conducts electricity. Recap. You know very well, universe is made up of 2 types of entities, matter and energy. The different types of substances that are present around us are solids, liquids or gases. Solids possesses rigidity and liquids and gases possesses fluidity. I need not say about fluidity. You know very well, they have the tendency to flow. Now the important properties of solids. Solids are rigid. Why they are rigid? Due to the fact that their constant particles have fixed position and they can only oscillate about their mean position. And because of the rigidity, solids have definite shape and definite volume. And so we can give the definition for solid. Solid is defined as that form of matter which possesses rigidity and hence possesses a definite shape and a definite volume. And why do some substances exist as solid? A substance will exist as a solid or liquid or gas depends on the net effect of the following 2 opposing forces. One is the intermolecular force. This I told already. Solids, the intermolecular force is very, very strong. And a liquid, it is less, and it is least in the case of gases. So intermolecular forces and the thermal energy only fixes the substance physical state, whether it exists in solid state or liquid state or gaseous state. And in solids, thermal energy is very low and intermolecular forces are very strong. So the general characteristics of solids, I told already, the constant particles are closely packed. The constant particles occupy a fixed position, but they can only oscillate about their mean position, and they are rigid, they are incompressible. This I discussed already. Now coming to the classification. Crystallines, now we discussed already, the solids can be classified into many ways we can classify, and the major types are crystalline solids and amorphous solids. Now in the table form it's given the difference between crystalline and amorphous. The constant particles are arranged in a regular fashion containing short range as well as long range order. But a crystalline means the major is what? Long range order only. And the constant particles are not arranged in any regularly fashion. There may be at the most some short range order only. They have definite geometrical shape, they have irregular shape. They have sharp melting point, they melt over a range of temperature and they become soft. They are anisotropic in nature, they are isotropic in nature. Anisotropic, again I am repeating, anisotropic means the physical properties like refractive index and electrical resistance, they are different in different directions. Their values are different in different directions when you measure. But here, in the case of amorphous solids, they are isotropic in nature. So when you measure the physical properties, the values are same in all the directions. They undergo a clean cleavage when you cut with a knife. They undergo an irregular cut. They have definite heat of fusion. They don't have definite heat of fusion. They don't have smooth cooling curves. Here they have smooth cooling curves. They are true solids. They are not true solids. They are pseudo solids or supercooled liquids. It is a recap again on crystalline solids classification. Crystalline solids are classified into 4 types I told already: ionic solids, molecular solids, covalent solids and metallic solids. And what type of particles are there in ionic solids? Ionic solids, the constant particles are in the form of ions, positive and negative ions. And what type of force, the nature of binding force between the ions? It is a Coulombic force or electrostatic force. An example: sodium chloride, lithium fluoride, magnesium oxide, zinc sulfide, calcium fluoride. And their physical nature, they are hard but brittle. And electrical conductivity, they are insulators in the solid state, but they conduct electricity in the molten state or in the aqueous state. Melting point is very high. And other characteristics, they are soluble in polar solvents but insoluble in non-polar solvents. Next, coming to molecular solids, again 3 types are there: non-polar, polar and hydrogen bonded. Non-polar, the atoms of noble gas are non-polar molecules, and the force between the constituent particles are London force or dispersion force. Example: argon, H2, I2, solid carbon dioxide, that is dry ice, methane. And the physical nature, they are very soft. And electrical conductivity, they are insulators. And melting point is very low and low density and volatile. Next, coming to polar molecular solids. The polar molecules are there, they are in the molecular form, and the force is a dipole-dipole attractive force, that is Keesom force. And examples: hydrogen chloride and sulfur dioxide. They are soft, they are insulators, and their melting point is very low. Next is hydrogen bonded solids, crystalline solids. The molecules containing hydrogen linked to fluorine or oxygen or nitrogen. The force is the hydrogen force. Example: H2O and ammonia. And they are very soft, they are insulators and low melting point. Next, coming to covalent or network solids. The constant particles are atoms and the force is a covalent force. Example: carbon and diamond form, and SiO2 quartz, and SiC silicon carbide, and aluminum nitride. They are very hard and insulators and melting point is very high. Next, metallic solids. The positive ions in the sea of free mobile valence electrons. Metallic force is there. Example: all metals and alloys are coming under this category. And physical nature, they are hard, and electrical conductivity, they are conductor in the solid state as well as molten state. Melting point is very high. They are ductile and malleable and lascivious.